Hello, I'm Robert from Doomsday Debunked, where we fact-check the stories that scare you by looking at and see what's actually true. So this time I'm going to be talking about large asteroids, and the fear many people have, mainly because of sensationalist press, and they want all these stories that are just completely made up. But there's a truth behind it, that we do get hit by small asteroids especially, quite often. But you need to put this in perspective. So I have this image. It's not meant to be at all realistic, but the Egyptians weren't so very far away from inventing modern technology. And just suppose that they had made those few extra steps, and they had invented telescopes like we do, and they'd had the spaceships and the telescopes and everything, and they'd set up a system of space telescopes to look out for asteroids in order to warn us if something was going to be harmful. Then, to put it in perspective, their telescopes would still be sitting looking for asteroids. They would not have yet launched any rockets to deflect them. Their rockets would be standing idle wherever they had them, just rusting over the thousands of years, or expensively maintained in immaculate condition if they managed to keep going. And they would have had a warning for the Tunguska, and they could have saved 3 reindeer herders and some reindeer in 1908. They could have saved lots of people from flying glass in Chelyabinsk and getting quite serious injuries, but they wouldn't have needed to deflect anything yet. So the really big ones are very, very rare. And now, where have we got it? Goes the splash one. I'm trying to find this one. There we are. So the last time we had a 1 kilometre one, which is just big enough to have some global effects, is 700,000 years ago. This was before the Neanderthals. Homo erectus was the first very early tool-using hominids. And here, there's, I think I've got some pictures of primitive tools. Maybe I haven't. But they did have primitive tools, and they would have seen this impact if the ones that were nearby. And that's the size of the debris field. So these things do happen, but they're very, very rare, and that would have that's the size where you would have a few weeks of losing the crops maybe, or crops being not so good because it's cooled by the clouds of dust in the air, which darken the daytime just a bit, enough to impact on crops, make things a bit colder, and by the next year even you'd have hardly any effects left. And it goes up. So if it's 10 times the diameter, it's 1,000 times the mass. So the one for the dinosaurs was about 10 kilometers across, 1,000 times more mass and energy than this one. And those are extremely rare. Every 100 million years or so. The last one 66 million years ago. So these are very rare. Now we have the telescopes, and if I bring up, see if I can find it, discovery statistics. So this was started, the reason it just started about then, we could have built these telescopes before then, but they started as a special program to look for these things. A special program, we have telescopes just dedicated to it, only looking for asteroids. It was a result of a comet that hit Jupiter, and before then people knew about it theoretically, but they didn't really take it very seriously. And it was only when a comet hit Jupiter and scientists kind of woke up and said, look, a comet's hit Jupiter, maybe something could hit Earth. And so they then started looking out for these asteroids. But most of them, Jupiter is like a big thing that just protects us from these. An awful lot of them hit Jupiter that don't come to us because they hit Jupiter first. It turns out, as they come in from the outer solar system, then Jupiter tends to break them up first. It's not like they inevitably hit Jupiter first time around, but there's a big tendency to hit Jupiter, and a big tendency to get broken up by Jupiter, and that's why we don't get hit by really big ones. And most of even the medium-sized ones, like the dinosaur one, most of them would hit Jupiter first if they're coming from way out there. And the other kinds we have are the asteroids, from the asteroid belt, and those go into short period orbits, and they're very easy for us to keep an eye on, comparatively. So we found 901 of those, of 1 kilometers and these are the near-Earth asteroids, that is thought to be about 95%. So there may be another few dozen left to find. And they find them every month or two. And we expect to nearly finish that by the end of this decade. And really, the risk is extremely small. Out of those 901 asteroids, there's only one that is still in the risk list, which is expected to miss, but it's got a tiny chance of hitting in 2880, so 4 centuries away. No, not 4 centuries, 7 centuries away or something. 2100, 2000. We're in the year 2000, sorry, 8 centuries away. And that's what you'd expect, because they're very rare. I mean, it's most likely the next one's going to be hundreds of thousands of years from now. And we found one that's expected to miss, but a tiny chance a few centuries from now. And out of the remaining, and that's 95% of them, so in the remaining 5%, it's very, very unlikely that we find another one like that. And if we do, it's likely to be centuries in the future, and for it to be decades in the future would be very, very unlikely. And at 1 kilometre plus, at 1 kilometre, we could deflect that. And we could do that without even needing to use nuclear weapons if we have plenty of time. So that's, you don't need to, these people are just playing games, they're just sensationalizing things. But see, we can't say that it's totally ruled out yet, the 1 kilometre ones, but we do expect a fair bit of warning. Now, and again, I'm told that we can't 100% even say that we'll totally see it in advance. But this is the Atlas, and we've got these telescopes, 2 telescopes in Hawaii, one there and one there. They have 2 because it helps a little bit with binocular for the distance for nearby ones. And they're going to be rolling out more, and there are many more telescopes being rolled out in the future. And this was a simulation of lots of, it is optimized to look at asteroids that are headed towards us. And in this simulation, you see nearly all of them at the 1 kilometre size, which is up to this size. Nearly all of them, almost more than 99%, something like 99% or something, are seen at least a year in advance of coming towards us. And this is just simulating the Atlas system, and we have several other telescopes as well. So although people say that theoretically we could have very little warning, in actuality we've been looking at these things for a decade, and it's very hard to see how. I would like to see a proper paper about this. People just say things, but I haven't seen any proper paper about this. And if anybody knows a proper paper, then do say. I've looked, but it's not a preoccupation for them for some reason. But it's hard to see how, because we have lots of telescopes looking at the sky, and they can look over nearly all of the sky except in the direction of the sun, and they see a 1 kilometre diameter asteroid a long way away. That's why this one would be seen like the previous very far away, and that's why they can see it, and why they see it so far in advance. So, and for one of them to have been, and we've now had these telescopes looking for a decade or more, and for one of them to have been not seen all this time, then it's hard to see how it could be missed, except if it's almost the same orbit as Earth. And so this is in one of the papers that I read, and it said the most likely place that for any that's been remaining is if it's almost the same orbit as Earth, and it's hiding behind the sun, and just gradually going to peek around the sun. And if that did happen, it would have an awful long time before it got round to us, because it's been hidden behind the sun for 10 years. So, although it seems they can't absolutely say this for certainty, but maybe I don't know if the more up-to-date research will say this, but it seems it's not at all likely that we get one without at least a year of warning. And as I say, most likely it's going to be between centuries, decades to centuries, for 1 kilometre size. So, and really the attention has been more. It's more at the smaller asteroids now. And so I just want to first of all, I'll talk a little bit about the long period comets. So those were about the asteroids. We do have the possibility of a comet, which comes from much further away. And those can be, well, Hale-Bopp is really huge, and some of those are pretty big. But what you've got to remember is how huge our solar system is, how tiny Earth is. And although and how these comets can be seen from a vast distance away, because they're very flimsy tail, but it can spread out to the size of the sun, of just sort of gas and dust, which reflects a lot of light, even though there's hardly any material there. So we can see them right across the other side of the solar system, and typically they're at least the distance as far away as the sun. So there aren't nearly as many comets of the long period ones as you would think from the amount of times that you see them in good telescopes. You'll see several of them every year, and the really bright ones every few years, but these are vast distance away. You talk about years and years and years of travel if you were going around, traveling at the speed of, say, a 747 to get to them when at the closest. And the closest that any of them has got is Lexell Comet, at about 6 times the distance of the Moon, which is several months of travel at the speed of a 747. And so Lexell's Comet, and it was in 1770, and it's closer to Earth than any other comet in recorded history. Apart from, they don't seem to mention it there, but there's a tiny little fragment of, oh yes, there we do mention it. It has been beaten by a small sun-grazing comet, which passed even close. That's only a few meters across. So that hardly counts. And so this one, and it was discovered, and the Lexell's Comet, then it came from, it seems to have done a flyby of Jupiter first, which took it into a short period orbit, which took it around, which then it flew within 6 times the distance of the Moon, very great distance of the Moon, and then from the Earth, then it flew out again. And this hasn't happened again since then. So it's extremely rare, and that's still very far away. And I just want to say that we can actually deflect them if I can find the methods for deflecting asteroids, deflecting comets. So this, we don't have this yet, but the breakthrough starshot, this is a thing we can practically make. It's 100 gigawatt infrared lasers, and they just heat up. It's difficult to keep this going for any length of time, but it just fires up for 8 minutes in the day, stores a lot of power, it all goes out in those 8 minutes. And this is a practical thing that we could make, which would be used to power tiny little spacecraft with solar sail kind of sails that could go flying through to Pluto in a matter of hours, and we could learn a lot about our solar system, and the aim is to eventually be able to send them to other star systems. So if we do build this, and there's a billionaire who's trying to get this thing underway, and if someday we do build this thing, then we could use this to deflect comets as a second objective, a second way of using it. And this, he looked at, if you used it for a comet you discovered 2 years before it got here, 5 kilometers in diameter. Now, if you had an orbital thing, then nearly all of them, this is the number of Earth diameters you can shift it by. And because you're not quite sure where it's going to head, and you've got the jets of the comet as well, then you want it to be at multiple Earth diameters away. And this number of Earth diameters it's away. So that's comfortable. And especially up there, then most of them, if you had an orbital one, then you could deflect them many Earth diameters away from. So you spotted enough time that just sending a little heating pulse 8 minutes a day towards this comet from the Earth. So that's an orbital, in orbit around Earth. This is an array in the northern hemisphere, the southern hemisphere, and that is in the northern hemisphere. If you have 2 of these on the ground, one in the north and one in the southern, which is much easier than an orbital, is the same as the orbital. So I think that's sort of doubling distance. Anyway, you can go and read up that paper. So it is practical to deflect even the large comets, and there are other ways of doing it, but this is perhaps the the most straightforward way of doing it, and which is something we could feasibly do. So we could build a defense system for the comets at the same time and collaborate with these people who want to send things to other star systems. It's feasible. It's something we could do for much. I don't even know what the cost would be, but we're not talking about like if you can build a modern destroyer, you can certainly build this sort of thing. So, but it's not our priority at the moment because these things are extremely rare, and the big asteroids are rare enough, and then these long period comets, we just have very few of them at the present, because they fly past at great distances. They fly past at a distance of further than the sun, and the closest any has got is just 6 times the distance of the moon. So, they can be deflected if needs be, and the small ones certainly can be, really easily, some of them. And then I just want to talk about how we're going to have a splosh in the. You don't need to worry. Just about the splosh. Well, that's part of them being less scary than lightning. Where's my Splosh article? Oh well, I think this one is this one will do. Oh yes, that one where I had the no, it was that one, the one where I had the yeah, that's it. That's the Splosh one. Okay, so that's the cherubims where it was the shock wave, a bit like when you have a supersonic jet or something, and it creates a shock wave. That's what blew out the glass. And so now, if we had a real asteroid warning, then it's most likely thing we're going to find, because you saw from those discovery statistics, and this is only a tiny fraction of them. Discovery statistics, and most of them are very small, and especially bearing in mind that actually it's very difficult to spot the smallest ones, so that it's vastly more than that. That's not the proper proportion. So it's very likely the next one, which is about maybe 80 years or century, that we'd be hit by one of those, is most likely going to fall in the sea. This is the most likely place for the next one to land, in the middle of the Pacific, and it'll be too small for a tsunami, that size, the most expected size. And then if you look at it, and then for the land, if you look at, I did this calculation based just on land areas, so most likely the next impact is going to be like that. Then it could be ice sheets, it could be in grassland, could be in deserts, forests, crops, getting more unlikely, and then this is the urban or semi-urban area. So in the next, say, 8,000 years or something, maybe one will be impacting on an urban area. So your risk from these is very, very tiny, personal risk. We do need to do it, but it's far less scary than lightning, or even than hailstones. So somewhere, and sometimes you hear this thing about potentially hazardous asteroids. This just means that there may be a chance, it's not even sure, there is a chance that it would hit sometime in the next 20 million years. So don't worry about potentially hazardous asteroids if they're not actually in the risk list. So there you are, 1 in 280,000 for lightning, 1.6 million for meteorite. And I don't know if I have that there, but it's like, and the asteroids, they can't suddenly swerve. They're just falling under gravity, and they can't. It's just like if you were to throw a ball in the air, then it is possible the ball could be moved. As soon as you left your hand, it's out of your control, and it could be blown around in the wind, perhaps. Well, the nearest that you have, like wind for an orbiting asteroid, is just the very, very feeble pressure of the sunlight from the sun, and that's not going to cause it to suddenly swerve. Just very gentle change over a period of time. So they know these orbits very well, and it's like, I mean, it's like a golfer, and you hit your golf ball, and as soon as it's left the club, there's nothing they can do to it anymore. And if there isn't any wind, if there's a strong wind, it could move it, but there isn't anything like that in space, then it's already set where it's going to land. And it's the same way with the asteroids, that as long as they know the orbit well, then they can know. And these tiny effects, they don't make any difference unless it's coming very, very close to Earth. So these people know what they're talking about. They've been following these things for years, and they know how to predict them. And yes, so yes, if I go back to that one, where was it? Did you know? And I go a little bit further down. So this is the most likely is a splosh in the Pacific. I've got a little image of a jet plane, because probably astronomers would they'd probably hire a jet. Imagine it would be quite a sight. So if it splashes in the sea, then this could go up a couple of 100 meters for a moderately sized one, and then it just splashes down again. But it doesn't create a tsunami. For a tsunami, you would need a really big, absolutely huge. The kilometer ones, even them, they're not quite in the same league as the tsunamis we get from earthquakes. Because what makes the tsunami, apart from that they can be very big if you're close by, so a 1 kilometer one would create a mega tsunami if it happens close to your city, but the wavelength of the wave that it produces, it's reason they spread out over the ocean so much and they pile up so much is because the wavelength is much bigger than the depth of the ocean. So that's a situation where you get a proper tsunami, like the one in Japan, and then it's maybe 100 kilometers or more, and it just comes and comes and comes, and it spreads without hardly dissipating at all the way across the ocean. And then when it gets there, it piles up and up and up. And this sort of thing, this is too small to produce even a few centimeters of tsunami. It just can't do it. It just splashes in the air, and then there's a great cavity forms there that pulls the sea in again, and hardly anything goes out. So that's a very harmless splosh. That's the most likely. And then if not, it's likely to happen on the land in some remote area, like the Siberian one we've already had, of the Tunguska one. And don't worry about people. We have actually had a few predicted in advance. Here's some examples, ones we've actually predicted in advance. So we can predict very small ones. We have done them. They're very, you miss most of them at that size, but it's a fireball size. And there'll be no warnings about those because they're too small to harm anyone. But we have had warnings for very, very small ones. This is an example. That's a bit of it that they found. A bit of a predicted asteroid, the first predicted asteroid hit. And that's another one. So there have been a few predicted very small ones. That's a video of that was predicted, and then it was videoed. So you see that splash? That's a fireball. It's actually it's harmless because all that's happening in the upper atmosphere. That was predicted. And these are all the telescopes. They're planning lots of new telescopes to help look for these. Atlas is already in Hawaii. They're going to have one in the southern hemisphere, and this is going to help a bit because there's a bit of a gap in the southern hemisphere for looking for them. And this is a telescope, a huge telescope they're going to build, which is somewhere there. There we are, large synoptic survey telescope in the southern hemisphere. It can see 4 times further away than any of the others. It's early 2020s. And in the first week, it's going to find vast numbers of asteroids that all the others have missed because it was flying past too far away. So it's going to help fill in the gaps with the small ones. Now, there have been people killed by the very small asteroids, even the ones too small to make a crater. Then sometimes the bits of them do fall from the sky, and it's like people die of hailstones. And so people do very occasionally die of very small asteroids. And this is an example where 8 people were killed in the hamlet of Santa Ana. And so there's a risk, but it hasn't happened in the United States. last century or the century before, and there's one story which is now known to be fake. And so those 3 people in Siberia, as a personal risk, it's far less than your risk of being killed by a hailstone. And that's a very unusual risk, but it does happen to people every year. And it does happen. Sorry, I don't know if it happens every year. The last time it happened in the States was in the year 2000. It does happen in other places worldwide. And it used to be much more common death in the States when there are lots of people working out of doors in the fields, and they got lots of hail. And there were more deaths by hailstone in like the early 20th century, but nowadays it's very rare because it's an uncommon thing anyway, and then you don't have the people working out of doors in large numbers that you would need to make it something that could happen with any significant risk. So you don't have much of a risk from hailstones, and you have even less risk from asteroids. So I can't say that that nobody's going to die of an asteroid, but it's very, very, very unusual and rare thing to die of. And this is new way of these ideas of ways of detecting. Right, this is about how a space telescope can look really close to the sun. This is the SOHO telescope. It's not actually searching for asteroids. So there's an idea for, it's called, this is it, but this near Earth object cameras. So if they can put these cameras in orbit and small and not very big spacecraft, it's not nearly as big as it looks, then this can make a big difference to finding the small ones quickly. But the somewhere I've got one. Oh yes, methods of. Yes, there's I don't think I have it here, but there's a Russian method idea for putting a telescope between the Earth and the Sun. In the L1 position is a place where it's hovering, balancing the gravity between the Earth and the Sun, and then if it was looking towards the Earth but at an angle, and it has a kind of spinning mirror a spinning secondary mirror which is reflecting, which then deflects light so that it can very quickly observe, in a few minutes, observe a kind of conical direction with the Earth in the middle of it. So you've got the Earth there, and then a conical thing like that. So it's a kind of shield, a guard, looking at a guard at a distance from the Earth. And then it would not spot any asteroid that's crossing it in just the few minutes it takes to cross that conical shield. And this is a possible thing that we could put into space, and any small country could do that. It's not a big, expensive mission. UK could do it easily, even Botswana or something, some small country that hasn't got a huge GDP could do this, or a winner of a lottery could do this. One of these big lotteries, if you one of the big lottery winners, you could afford to buy a telescope to go up into space that would then be able to protect Earth and be able to spot even small asteroids from the direction of the Sun 2 days before they got here. If you got warning of an asteroid, then you could evacuate just like you do for a hurricane. And you get these people claiming that everyone knows, that the governments know that we're about to be hit by an asteroid and they're keeping it secret. No, they wouldn't do that. That is just a movie myth. It never happens in reality. And if you look at just look at hurricanes, and they don't tell the weather forecasters to shut up and close the weather station down because they forecast a hurricane, and then pretend to everyone that nothing's going to happen. That's just not what governments do. But it's a real risk for their own citizens. It's said they're the other way around. They're out there telling people, get out. We're not certain if it's going to hit Miami or whatever, but just get out because there's a risk, and we don't want you to take that risk of dying. And so that's what the government does. They don't hide these things. They're the people who are out there trying to get people to move and do something. and so this was one, and we know from the experience of hurricanes that we can evacuate a city in a couple of days. It's not likely to happen. The chances are there's going to be thousands of years before we have to evacuate a city. But if we do have to, then we are in a very different situation from the dinosaurs. We can do this. And as for something big enough as like an asteroid one, oh yes, and I was just going to show you, these are all the ones that are list of the, I should have done a little bit more careful preparation of this. There we are, where's my list of methods deflecting? Oh, here we go. These are the ones. No, that's not the one. I just have to quickly bring it up. If you give me a minute. I'm just going to bring up the ones that are. So I go to their supplementary. I'm going to bring up the list, the complete list of the big ones. So here we go. This is there are only 8 of them, of the near-Earth objects of 10 kilometers or more, 4 asteroids and 4 comets. And so we have this one. It's not likely to hit Earth ever. In orbit, likely to be ejected from the solar system, hit the Sun within 10 million years. See this paper? So there's a paper about that one. So that one's okay. This one and these ones, none of these are risks in the near. This one does have a very small chance. It's got a 50% chance of becoming an Earth crosser in 1 million years. And if that happens, it's a very tiny chance of hitting Earth eventually. So that's plenty of time for our descendants to do something about it. You don't need to worry about these. And then this is another one. And most of these are not even a risk at all. 1 chance per million. Now this is the only one that's got a serious risk. And not really a serious. 1 in a million means forget about it. But in 4,479, so a couple of thousand years from now, then Swift-Tuttle, which is a really big one, we don't want that to hit Earth. It's got a 1 in a chance in 1 million. But remember that I said that we can actually deflect comets already. If we just need to build this thing, which we could do in a few years if we had the funding for it. So there's no doubt, and this one, if we ever need to deflect it, as long as we keep our technology, then we can make sure that doesn't hit Earth. And that's it. I think those are the only ones that that you really need to do anything about, and that you need to think about. Those are the only ones at 10 kilometers. There are a couple that's a little bit short. There's one of 7 kilometers, and none of these are a risk. And it's probably complete down to 5 kilometers, though they haven't necessarily measured all the 5 kilometer ones. And the largest one left to find is probably about 3.5 kilometers. So that's about 1/3 of the diameter of the dinosaur one, which means getting along that's long for 1/10, not quite 1/10, maybe 1/8 or so of the mass of the dinosaur one. So it's much, much smaller in terms of its effect. But it's very, very unlikely. These are the numbers that number left to find. And when you get down to 3 kilometers, you get that it's like 3 kilometers about 1. There might be 1 left to find. There might be 3 left at 2 kilometers, and 8 at that size, 16, and it might be 33 left at 1 kilometer or larger to find. And remember that out of 901, only 1 had a very tiny chance of hitting in 2,880, and is expected to miss. So, although we can't say yet until they've completed the survey, which will take another decade or so, it's very unlikely to even find that there's one going to be hit even in the next few decades, or even the next few centuries. And most likely, for the big one of 1 kilometer or larger, you're talking about probably several 100,000 years that we've got in order to deflect it. So it's good that we're looking out for them. We're a lot better than the Egyptians, and we do things that would be absolutely impossible for the dinosaurs, but it's really on the very long term or for the very small ones that's where it's all about. And with Asteroid Day, they're kind of motivated. They're sort of going saying, we could be hit by something like the dinosaurs. I think it's partly just they're sort of dramatically trying to get the message across that we really can do something about this. But it is rather, I think an alien species would find it rather strange that we put a more advanced, more civilized alien species, extraterrestrial, and so they've looked at us and they think, in a very early primitive stage, they've still got all these. They spent billions and billions of dollars on weapons to fight each other, ICBMs and submarines and destroyers and things, and they haven't yet put a small $100 million telescope into space to look for asteroids. What are these people? Are they idiots or something? I mean, should they really think that they should devote all their efforts to looking at each other rather than looking into space to try and find the asteroids? So at least we're looking for the telescopes based on the ground, and part of it is they are actually spending quite a lot on these ground-based telescopes. But the thing is that they haven't got a ring-fence budget for a space telescope, and it's really almost a kind of organisational thing, bureaucratic thing. And NASA projects, so that NEO-WISE thing that I showed you, a telescope we could put up into orbit to look for these things from orbit, where if it's in orbit, you can send an infrared telescope into orbit, which can't see through. We can do some infrared astronomy from the ground, but the atmosphere absorbs quite a lot of infrared light in different frequencies, and we can do much more effective infrared astronomy from space. And that is especially useful for the darker asteroids, which are most obvious in infrared, where they're warmed by the sun and you can detect the infrared from that. So if we had a small infrared telescope in space, then we would find a lot more of the small ones much more quickly. And if we had a small infrared telescope as well, in between Earth and the Sun, and I think ideally we should do both. I don't really see why not. For less than, I think it's only 100 million for each sort of thing, for a few hundred million at most. You're not talking about billions of dollars. In fact, no, it was 50 million. It was 50 million for one estimate to almost complete, right down to very small ones, in 6.5 years, to find quite a lot of even down the smallest ones, by sending a fleet of about 8 small space telescopes into space, very small size, but using synthetic aperture tracking. And then there's this other one, this Russian soda idea, and that would be a similar kind of a price range, which would have 2 of them, which help detect them coming in, where they're coming our way. With $100 million, I think you could do both. And compare that with the cost of a submarine or just one ICBM, probably, I don't know. I don't know why people aren't doing that. And I think the extraterrestrials would look at us with somewhat bemused and wonder why we can't find $100 million to make a space telescope. It's partly a bureaucratic thing. And if one of these things, if you've got a member of Congress and brought it up as a member's bill and got enough enthusiasm going, then it's sort of thing they could pass and say, we need to do this. And it wouldn't, one enthusiastic senator is probably all or congressman is probably all it takes to actually launch this thing and have a little ring-fence budget. Because the problem is it can't compete with the NASA science objectives, because the NASA, they have to evaluate their missions according to the science value, and it keeps getting beaten by much more scientifically interesting, because although it is scientifically interesting to find all these asteroids and kind of categorize them and so on, it's not as scientifically interesting as, say, landing a helicopter on Titan to look at, which is one of the ones that's underway now. So it's no wonder that NASA keeps, because NASA is obliged to judge its missions on a science merit. So it's a kind of bureaucratic thing, really. It's just because it's it's fallen under NASA's purview, but they're very rationale of what they've been told to do automatically disqualifies this. Makes it very difficult for this to compete. So anyway, but it's still worth doing. It would probably just save a few lives of a few people, but still that's well worth doing. Save a life for a sailor if it splashes in the Pacific or something, and then there is the small possibility that there's something larger, that you'll detect it very quickly. But if not, if they don't make these space telescopes, send a space telescope up in the next decade, then sometimes in 2030s or 2040s, we're going to already be tracking just about all of even the smallest ones. And then if we do find one headed our way, and deflecting is certainly something we can do, especially for the very small ones, which is the most likely. So I hope that helps a bit. And any questions, do say. And of course, if any of my videos, if anything I've said that needs correcting, and do say that as well. And I'll put some links in this video description so you can go and find out more. And do remember about our Doomsday Debunk group on Facebook, where I'm a few of us who go there to help you search out and find out about these stories when you get scared, and to actually do the searches properly. Because if you just go and search on Google, unfortunately, in some topics like NASA asteroid, don't search for NASA asteroid warning. If you do, all you'll find is pages and pages of totally fake news by the Daily Express.